Let's just jump right into it. In this explainer, we're breaking down a fantastic tutorial from Mark TechPost, written by Sana Hassan. She walks us through building a modular document intelligence workflow using the III engine. You know, if you've ever felt stuck in that experimental phase of coding, just kind of tinkering around, running scripts, but not actually building something scalable, well, the concepts we're diving into today are going to be an absolute game changer for you.
Right off the bat, we have to ask the million-dollar question. How do you actually turn a static, rigid script into a dynamic document intelligence backend? If you're a developer looking to graduate from those basic Python notebook demos to robust, breathing systems that can handle real-world tasks, well, this is exactly what we're answering today. It's really all about evolving your code.
We're basically going on a builder's journey here. We're transitioning away from a single static script, the kind you might whip up for a quick proof of concept, and moving toward a flexible, trigger-based architecture using the EE engine. It's that massive leap from a localized, works-on-my-machine experiment to a system that feels, acts, and operates like a true production-ready backend. So, here's our roadmap for the build. We've got 1. From script to backend. 2. Setup and connection. 3. Defining core functions. 4. Triggers and execution. And finally, 5, testing the workflow. All right, starting with part 1, from script to backend, setting the stage. To get things off the ground, we first need to set up the local binary path for the III engine. We define a quick helper function to run shell commands, which very conveniently installs the engine if you don't already have it installed. Then we just grab the Python SDK along with the requests package, and we verify the whole shebang by checking the III installation version. Simple enough, right?
Moving right along to part 2. Setup and connection, laying the foundation.
There's a really deliberate sequence to follow here. First, we launch the II engine, but, and this is key, we do it as a background process. We then wait for its WebSocket port to open up. This is basically the engine's way of saying, hey, I'm awake and ready to listen. Once that port is open, we securely connect our Python worker to it. Think of this worker as the crucial bridge. It's what actually executes our Python code inside the engine's environment. But, a true backend needs to remember things, right? So to give our workflow some basic memory and to prep it for fire and forget triggers later, we define a shared in-memory state. We also throw in a thread lock. Now this is absolutely crucial to keep everything safe and synchronized when you inevitably have multiple tasks running at the exact same time. On top of that, we set up some simple positive and negative word sets. These will act as our foundational vocabulary for the sentiment analysis we're going to be doing in just a bit. Okay, on to part 3, defining core functions, the magic of modularity. Here is where things get fun. Instead of writing one massive, terrifying block of code that tries to do absolutely everything top to bottom, we break it down. We register these discrete core functions with the worker to handle very specific text analysis tasks. We're talking separate, distinct functions for text normalization, tokenization, sentiment detection, using those exact word sets we just talked about, plus keyword extraction, reporting our results, and even tracking a heartbeat just to ensure the system is actually alive and kicking. So, the big takeaway here is how this analysis function acts as a pipeline. It orchestrates all those smaller functions incredibly efficiently through the engine. Instead of your main Python script directly calling the normalization function and then the tokenization function, it routes every single step through the EAI engine. It's essentially acting like a smart traffic cop, smoothly managing the flow of our document intelligence process from one discrete function to the next. Let's look at part 4. Triggers and execution, expanding access. Because we've gone through the effort of modularizing our functions and hooking them up to that central router, we can now run the exact same text analysis logic through 4 entirely different execution paths. This means no more rewriting your code for different environments. We can use direct invocation, hit an HTTP endpoint, trigger a fire and forget asynchronous execution, or even rely on a scheduled cron trigger. This brilliantly illustrates the flexibility we've unlocked. We can literally trigger the pipeline via a web request, like an on-demand HTTP post request right from a web interface. Or we could run a heartbeat function on a fixed recurring schedule using a cron trigger, assuming your engine build supports the cron schema, of course. It is the exact same core logic, but now it's accessible to completely different parts of your broader application architecture. To wrap up the setup phase, right after registering those HTTP and cron triggers, we finalize the worker connection. And then, the tutorial includes a very small but honestly super important detail. We pause, just briefly.
This short pause ensures the system is fully primed and that all those registered functions and triggers are locked in and genuinely ready to go before we start throwing actual data at them.
Which brings us to our final step, part 5, testing the workflow, grounding theory in reality.
The tutorial rigorously tests this complete IAA workflow. Step 1, we send some sample text documents straight through our direct analysis pipeline. Step 2, we test our web access by calling that identical logic via the HTTP endpoint. Step 3, we test the async fire and forget execution to make sure our background tasks are actually working. And finally, step 4, we verify that our cron heartbeat is pulsing right on schedule.
But, as you know, to make this feel like a true backend system, you absolutely need to be able to see what's happening under the hood. So the final step involves printing an aggregate state report from that shared memory we set up earlier and checking the engine logtail for basic runtime visibility. This is what gives you the observability required to actually monitor and debug a living, breathing system. The source article perfectly summarizes this 0 to 1 progression with a core philosophy for efficient, reusable system design. Define your functions once, register them with a worker, and reuse them everywhere. It prevents nasty code duplication, makes debugging so much easier, and allows your whole system to scale beautifully. So, now that you understand how small, distinct functions can be cleanly connected into a production-ready document intelligence workflow using the III engine, you essentially have a blueprint for your own projects. The only real question left is, what static script sitting on your hard drive right now will you transform into a dynamic, modular backend system next? Get out there and start building.